This is half past paper week 27 for the higher tier calculator paper this week, and all of the odd numbers, 41 marks out of a possible 80. The even numbers we'll do next week, and that will make up the other 39 marks. They're the Sparks codes there as well if you have Sparks and you want to do more practice. Okay, question number 1. We've got the universal set. So this funny squiggly E means the universal set, and you need to think of that as all the numbers that you know about in the world right now. That's everything you know about. You don't know anything else beyond that. That is your world, if that makes sense. So everything in that universal set needs to go inside this box. We've got that funny squiggly E up there in the corner as well, and that is all the even numbers between 1 and 25. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 and 24. They are all the numbers in my universal set, and they all need to go somewhere inside that rectangle. So in A we've got 2, 8, 10 and 14. In B we've got 6, 8 and 20. And in C we've got 8, 18, 20 and 22. So if we've got a number that's in A, B and C, that needs to go in the middle, and we've got 8. That's in all of them. I'm actually going to cross them off as we go because this one's quite a confusing one. Now that's the only number that's in all three. Now we need to look and see if any of the others have them in common. So B and C both have 20. So between B and C, I'm going to put 20 there. And then, are there any others in common? No, I think that's it. So in A, I've got 2, 10 and 14, and that's just in A. In B, I've got a 6, that goes out here. And in C, I've got 18 and 22. Now we're not quite done because there are numbers here that we haven't yet considered that are in the universal set that aren't in A, B or C, and they need to go on the outside. So I've dealt with 2, I haven't dealt with 4, so I'm just going to work through, and if there's any that I haven't done yet, I'm going to pop on the outside. 6 we've got, 8 we've got, 10 we've got, 12 we haven't, I'll put that on the outside as well. 14 we've got, 16 we haven't yet, so we're going to put that on the outside. 18 I've got, 20 I've got, 22 I've got, and 24 I haven't. So then I'm just going to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers in my universal set. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers in the box. So I'm happy that I've got them all, and that would be my final answer for 4 marks there. Now a number is chosen at random from that squiggly E, so from my universal set. So that means that we're picking from all of the numbers in the whole thing, and we know already that there are 12 of them, so this is going to be out of 12. Now you're going to get 1 mark for knowing that this is out of 12, so we definitely want to pop that there. And then on the top we need to make sure that we've got the right value here. Find the probability that the number is a member of A intersection B. Now there are 2 different types of questions you can be asked here. A intersection B means that it's in A and it's in B. And I remember that, I think those grabber machines at the arcade, it's very, very picky. It's only going to pick it up if it's in that middle bit. That's how I remember it. And then A union B, sometimes you get asked this one, and that would be anything from either A or B, including the bit in the middle. So think of that as like a bucket, and that's going to scoop them all into it. So if I want A intersection B, which is what I want here, I just want the values that are in A and in B. And if we have a little look there, there's only one number that's in A and B, and that's 8. So the probability of picking that number is 1 out of 12. Question number 3. BEG is a triangle. ABC and DEF are parallel lines. Work out the size of angle X. You must give a reason for each stage of your working. Okay, so we've got parallel lines. So we're probably going to need alternate. So I remember zalternate and corresponding angles here. So I remember zalternate and corresponding. I know it doesn't make any sense, but it helps me remember which one's which. And then you've also got, if you need it, co-interior angles. Now they're not the same, but they add together to make 180. So co-interior always add to make 180. Let's have a little look then. I know what this angle is, because angles on a straight line add up to 180. So I've got 110 and 25 so far, which is 135. Take that away from 180, more on the floor, borrow from next door. So that is 45 degrees there. Okay. Now, sometimes people will try and do this and tell me that this one's 45. When you're drawing the Z for the alternate angles, the top and the bottom of the Z needs to be on the parallel line. So we can't quite do it like that, but we can do it like this. So I can go along here, down here, and along here, which means that this angle here, the 45 and the 25, is equal to this one here, and that's going to be 70. Now you can also see that we would have got that if we'd have looked at co-interior angles here. So there's lots of different ways you could have done it. Now this angle here, again, angles on a straight line add up to 180. 70 add 35 is 105. So 180 take away 105 is 75 degrees here. And now I'm just going to add up the angles inside my triangle. So 75 add 45. 7, 8, 9, 10, 11, 12 is 120. And then I'm left with 60 degrees if I do 180, take away 120 for there. So X is 60. Now, so far we haven't written any reasons. So what did we use? We used angles on a straight line add up to 180 degrees. We also used angles in a triangle add up to 180 degrees, and I used the fact that alternate angles are equal. I don't think I used anything else. You could have used co-interior angles, add up to 180 there if you wanted to, but probably a few different ways you could have done that one. So just make sure that each step you've done, you've written a reason to show why you know that is the case. Okay, let me put the answer on the answer line, 60 degrees, there we go. Question number 5. The diagram shows a floor in the shape of a trapezium. John is going to paint the floor. Each 5 litre tin of paint costs £16.99. 1 litre of paint covers an area of 2 metres squared. John has £160 to spend on paint. Has John got enough money to buy all the paint he needs? You must show how you get your answer. So first thing we're going to do is work out the area of the trapezium. And to do that, we use the formula A plus B divided by 2 times by height, where A and B are your parallel sides and H is the perpendicular height. So for this, I'm going to do 10 add 16, all divided by 2 times by the height, which is 7. So that is 26 divided by 2 times by 7, which is 13 times 7. 13 times by 7, 7 times 3 is 21, 7 times 1 is 7, add the 2 is 9. So this trapezium has an area of 91 metres squared. Now each 5 litre tin of paint costs £16.99 and 1 litre covers 2 metres squared. So if 1 litre covers 2 metres squared, then a 5 litre tin of paint is going to cover 10 metres squared because it is 5 times bigger. And the more paint, the more area it's going to cover. So each tin covers 10. I can't go to the shop and buy 9 and a bit tins. So I'm going to do 91 divided by 10, which is 9.1, but I can't buy 9.1 tins. So I need, or he needs, 10 tins. We'd have to round that up. And so it's going to be £16.99 times by 10, which is £169.90, and he's only got £160. So we're going to say that's less than it's greater than £160, and therefore no, not enough. So we've answered the question for the 5th mark there. So he hasn't got enough money to buy the paint that he needs. Fabulous. Okay, question number 7. Write the number 0.00008623 in standard form. So we're going to take the digits 8.623 because we have to have a number between 1 and 10. We can equal 1, but we can't equal 10, but it needs to be between them. 8.623 times by 10 to the power of what? Now, because this value is much smaller than 1, we're going to divide by 10, divide by 10, divide by 10. How many times would we need to do that to get the decimal point here between the 8 and the 6? Now, I know it's the numbers that are moving, not the decimal point, but it's much easier to move the decimal point. 1, 2, 3, 4, 5. And because this number is really, really small, it's going to be times 10 to the power of minus 5. That tells us to divide by 10 rather than timesing by 10. So that's your answer to that one. And then for this one down here, 3.2 times 10 to the power of 3, add 5.1 times 10 to the power of minus 2, all divided by 4.3 times 10 to the power of minus 4. Now, I'm just going to type this in my calculator. So I'm going to use the fraction button. I'm also going to put each of those values in brackets just to make sure it does the right thing. So 3.2 times 10 to the power of 3. Shut the bracket, add, open the bracket, 5.1 times 10 to the power of minus 2. Shut the bracket, and then use the arrow to go down, and on the denominator we want 4.3 times 10 to the power of minus 4. Hit that equals, and I get 7441979.07, but they want the answer in standard form correct to 3 significant figures. Now 3 significant figures would be the 7, the 4, the 4. Checking the next number, a 1 rounds down. So we're going to round this to 7440000. And that, in standard form, would be 7.44 times 10 to the power of 1, 2, 3, 4, 5, 6. Always with the millions, it's going to be 6. So that's 7,440,000, so 7.44 times 10 to the power of 6. Standard form is the topic there. Question number 9. Martin truncates the number n to 1 digit. The result is 7. Write down the error interval for n. So truncating is different from rounding. If I have 7 and I've truncated, let's put a decimal point there, and I'm going to colour in here. Now, you could have any value behind that scribble, and it's not going to make any difference. If it was a 9, if it was a 0, it doesn't matter. We're basically just chopping it off. So what is the smallest value that could be behind that scribble? Well, it could have been a 0. It might have been 7.0. So at this end down here, now error intervals we do like this with an equal to at the lowest end, because it could actually be 7.0. So 7 is the smallest value that it could take. Or the biggest value that could be behind that scribble would be 9 recurring. Now that is basically 8. So we say we go up to 8, but we know it can't actually equal 8, or else you would have seen an 8 where the 7 is. So with error intervals, this one's going to be equal to, this one's just going to be less than, and we go up to 8. 7.9 recurring is the biggest it could be, but because that goes so infinitely close to 8, we just call 8 the upper limit just to make our lives easier. Okay, question number 11. In a restaurant, there are 9 starters, 15 mains and 8 desserts. Janet is going to choose one of the following combinations for her meal. So she might get a starter and a main, in which case that would be 9 times 15 different ways that she can do that. Because there are 9 starters and 15 mains, 9 times 15 is 135. She might, instead, get a main and a dessert, in which case there would be 15 times 8 different ways of doing that. 15 times 8 is 120. Or she might get a starter and a main and a dessert. Now there are 9 times 15 times 8 different ways of doing that. So 9 times by 15 times by 8 is 1080. So altogether there is 135 combinations for the first thing, then 120 and 1080, and if we add all of those together we do indeed get 1335 different ways to choose the meal. That topic is product rule combinations, so yeah, quite a nice one for 3 marks I think, as long as you've seen that sort of question before. Question number 13. The diagram shows a circle and an equilateral triangle. One side of the equilateral triangle is a diameter of the circle, and the circle has a circumference of 44. Now this is like telling us the answer. So circumference is pi times diameter, and that is 44. So if I divide both sides by pi, I'll be able to work out the diameter of that circle. So 44 divided by pi, that is 14.00563499. I'm going to keep it in my calculator. I don't want to round it just yet. So that is the distance from here to here. But it says work out the area of the triangle. Now, I also know then that this side is 14.0056. So this is 14.005. This is 14.0056, and so on. And I know that because it's an equilateral triangle, this is going to be 60 degrees. So rather than worry about getting the perpendicular height, I'm actually here going to use half AB sine C, which is how we would work out the area of a triangle when we've got two sides and the angle in between. So I'm going to do half times 14.00563499, which I've got in my calculator, and I'm going to square it because I'm timesing it by itself. It's both A and it's B, times sine 60. So typing that in my calculator, half times my answer squared times by sine 60, and that gives me an answer of 84.9388. I want that to three significant figures, so that's going to be 84.9. The next values are 3, so that rounds down. 84.9 would be my answer there. Okay, question number 15. The equation of a circle is x squared add y squared is 42.25. Find the radius of a circle. So the equation of a circle that's centred about the origin is x squared add y squared equals the radius squared. So I know that this is the radius squared. So in order to get the radius of a circle, we're just going to square root that value. So 42.25, the square root of that is 6.5. That's it. That's the radius of a circle. Question number 17. P and Q are two numbers such that P is bigger than Q. When you subtract 5 from P and subtract 5 from Q, the answers are in the ratio 5 to 1. Okay, so subtract 5 from P means P take away 5. Subtract 5 from Q means Q take away 5. Now, they are in the ratio 5 to 1. So P minus 5 to Q minus 5 is in the ratio 5 to 1. When you add 20 to P and add 20 to Q, the answer in the ratio 5 to 2. Okay, so P add 20 to Q add 20 is in the ratio 5 to 2. Find the ratio P to Q, give your answer in its simplest form. Now, I actually want to change these into equations, and we can do that. So this is where people often get a little bit thrown. This value here is 5 times bigger than this one. So if you wanted to make an equation and make them equal, you would need to make this value 5 times bigger and make this value 1 times bigger. So it's almost like you multiply the other way round in order to make them equal. So 1 lot of P take away 5 is equal to 5 lots of Q take away 5. So P minus 5 equals 5Q minus 25. So P is 5Q, and I'm adding 5 to both sides here, so minus 20. So there we go, I've got one equation here, that's going to help me. And then on this side, I know that 2 lots of P add 20 would be equal to 5 lots of Q add 20. So 2P add 40 equals 5Q add 100, and I'm going to take 40 away from both sides, so 2P is 5Q add 60. Now, if I double this one, I know that 2P, I don't know why I did the arrow over there, sorry. Let's take that way. 2P is 10Q minus 40. And then I've got 2P is this, but 2P is also this. So then 10Q minus 40 equals 5Q add 60. And I can solve that. So 5Q is adding 40, 100, so Q is 20. That's solved what Q is. Once I know what Q is, I can then work out what P is. So Q is 20, let's pop that back into here. 5 lots of 20 is 100, take away 20 is 80, so P is 80. Therefore, the ratio P to Q, which is what they wanted, we know that P is 80, and Q is 20, so dividing both sides by 20, I get the ratio 4 to 1. For 5 marks there. Quite tricky that one though. Question number 19. Solve 22 is less than m squared add 7 over 4, which is less than 32. Okay, so I've got a double inequality here. Now, you can take this and solve it, and then take this and solve it. That would work. Or you can try and work with it as all 3 things. I think I'm going to split them. So I'm going to start by multiplying by 4. So 88 is less than m squared add 7. And if I'm timesing by 4, m squared add 7 is also less than 128. 4 times 32 is 128. Okay, so m squared is greater than, if I'm taking 7 away from both sides, 81, which means, I'll come on to that in a minute actually, let me do this one first. If I take away 7 from here, m squared is less than 121. Now, with quadratic inequalities, we need to think about this carefully. Now, I think I might make it equal 0 just to kind of prove my point a little bit easier. If I take 81 away from both sides, m squared minus 81. So then I can factorise it. It's the difference of two squares, not 8, that's 9. M add 9 and m minus 9. So this quadratic looks like this. It crosses at minus 9 and 9. Now, where is that greater than 0? Well, it's greater than 0 here, and it's greater than 0 here. So I need to make sure that my solutions here are when m is less than minus 9, but also when m is greater than 9. Both of those values, as long as it's minus 10, minus 11, or 10, 11, when you square it, it ends up being positive, so it's going to be greater than 0. So that's one part of my solution. Same thing's going to happen over here. M squared minus 121 is less than 0, and I know that that has solutions at, I'm going to do the difference of two squares again, m minus 11 and m plus 11. So again, if you draw it, it's going to look like this, with solutions at 11 and minus 11. This time we want it to be less than 0, so that's going to be this bit in between. So that's going to be when m is smaller than, bigger than minus 11 and smaller than 11, like that. But I need both of these things to be true to be solving this equation. So let's have a think about this. We want between 9 and 11 here, and between minus 9 and minus 11 here. That would satisfy both of them. So I'm going to say m is bigger than minus 11 and less than 9, and m is greater than 9 and less than 11. And that is my final answer for that one. Very, very tricky quadratic inequalities there. Okay, last but not least, question number 21. A, B, R and P are 4 points on a circle with centre O. A, O, R and C are 4 points on a different circle. The two circles intersect at the points A and R. CPA, CRB and AOB are straight lines. Prove that angle CAB, so that's this one up here, and angle ABC are equal, so that's that one down there. Okay, what can I do first? Well, firstly, let's call this one X. Then if I take a line from here down to here, this is the radius of the circle on the right, and this is also the radius of the circle on the right. And because those two lengths are equal, I know that this angle here will also be X. So the reason I've used there is that radii are equal and base angles in an isosceles triangle are equal. Great. So now, using the fact that this is a straight line here, I know that this angle would be 180 take away X. And that's using the fact that angles on a straight line add up to 180 degrees. Now, if you look very carefully at these four sides, 1, 2, 3, 4, because all four corners, all four vertices are on the edge of that circle on the left, or on the circumference of that circle, that is a cyclic quadrilateral. A cyclic quadrilateral is when you have a quadrilateral and all 4 points are on the edge of the circle, and when that happens, opposite angles in the cyclic quadrilateral add up to make 180. So if this one is 180 take away X, then this one up here is X. Reason being is that opposite angles in a cyclic quadrilateral add to 180 degrees. So therefore we've got X up here and we've got x down here, so that's proved that they are the same. But a very, very tricky last question there. Circle theorems, but also using algebra, so that is the harder version of that topic. I hope you found that helpful, and I will see you guys next week for week 28, I think. Yeah, let me know in the comments if you need any help with any of those questions.